Hello guys, welcome again to this basic power system series. So, in this series, we are covering all these topics. Okay. For this video, our topic is foundations and distribution system. So, we are just covering basic things. Okay. And if you have came here for the first time, I would like to request you to subscribe this channel. I'm uploading videos on basic power system. Later on, I upload videos on advanced power system and basic electrical engineering also, and some other very important topics also. So let's start. The transmission and distribution system. Okay, we'll just go simple basic things. Okay, we have seen this figure in last lecture. Okay, that this is a single line that representation of typical power system. Okay, so power plants are normally placed far from localized area, you know, because so generated power need to transfer to the load through transmission line and need to distribute. From this first line is recorded power plants are normally placed far from localized area. You know that one. You will never see any power plant nearby a locality. Okay, nearby your village, nearby your town. You'll see it's a little far. Okay, little not. No, it's far from the locality area because there are like so many sounds, so many pollutions, and blah blah blah. Okay, so basically we need to because of that we need to transfer. Okay, this power generated in the power plant and distribute in the load means to the consumer to us. Okay, so basically it needs some transmission line and distribution line. So that is the transmission and distribution system in power system. Okay, supply system are maximum three phase. Okay, nearly equal load on each phase. Industrial loads are usually three phase and balanced, equally balanced. Okay, with load. So supply system are maximum three phase transmission line you have seen. Okay, that thing is same, the three phase, and nearly equal loads. So nearly equal loads are distributed between those three phase. Okay, suppose 5 megawatt, 6 megawatt, and 525 megawatt like that. It's not exactly same, nearly same. The thing is same. Bus bar. Okay, you. This is also important things here. This one is these are the bus bar here. Okay, this and this two are the bus bar. Okay, so solid electrical connections of zero impedance, aluminum or copper bar connecting various power system components like transformer, load, and all the components are connected to it. Okay, these are the bus bar. Okay, got it. Loads, yeah, a load are connected. Load device which draw electrical power from the bus bar to do useful work for consumers, light, fan, everything is all a load. Okay, it's consuming power from the line from the okay. And earthing useful at fault short conditions to ground fault voltage. Earthing without earthing, sometimes you'll see it will not properly run. Yeah, you may have seen at your home. Or not, I'm not sure, but I have seen. Means if there is if the earthing is not properly connected, na, it will not work properly. Okay, it will not. You will not be able to function your equipments connected in connected in electrical system. It will not. Sometimes it will not work properly. Okay, it will not function properly. So earthing is also good, important, very much important things. Okay, how earthing does maybe we have seen or not. I am not sure. Earthing from the earthing three pin plug, you know, no? Three pin plug. So two pin. Other one is earthing. Third one, laptop pin. That's in that bigger size one, that is earthing. And from your electrical board, extension board, there will be one connection that will go to earthing. Earthing means to the earth. Okay, here we are saying to the earth. It can be done in sea also, sea water also. Sometime the two for uh, high voltage HVDC also. So why interconnection in transmission and distribution system? Transmission and distribution system all are interconnected. That is, I think all are interconnected. Okay, like you can say parallel type connections are here. So in case of surplus energy, energy can be distributed properly. Okay, when there is extra energy, means suppose it delivering power to my home, but at my home it's fulfilling. Suppose it's sending 5 megawatt, but my at my home at first it was 5 megawatt, then suddenly I turn off some equipments, and then means I'm just assuming not 5 megawatt. It's like so much, that much for nothing. I'm just assuming. I'm just giving example. Suppose at first load was 5 megawatt, then suddenly some equipments are turned off. Then suppose the load it became 4 megawatt. So there is surplus energy 1 megawatt. So that surplus energy can be distributed to other consumers. Okay, so that's why it's easier when it is interconnected. In case of lack of power generation, can meet load demand. Same thing. If there is lack of power generation, suppose due to some technical problem or due to some any problem, there is from the the generation system, it is not able to generate the power that is demanded. Okay, so that surplus energy can be distributed to other areas. Okay, then proper distribution of power. Yeah, it's giving proper distributions. Okay, when it is interconnected. In case of failure of one particular generation system, other generation system can give supply. Suppose those are interconnected system, transmission, distribution, and generation also. Suppose there are three, four generation systems. One generation system, due to some fault, it's not able to generate power. So in that case, other parallelly connected generation system, they can give us supply. Okay, and adding and removing load can be done also easily. This is also one of the advantage, that we can easily add or remove components connected to it. Okay, so there is, when we add and or remove components or loads, there is change of demand. Okay, so that change of demand can be distributed easily. That means there will be not much problem when we are adding or removing some components. Okay, and distribution. Okay, let's see this. So voltage is stepped down to 130 kilovolt or 11 kilovolt to or 400 volt. Okay, single phase normally it is 230 volt at our home is supplied. So distribution is where from your nearby substations, from your nearby substations, the connection coming to our home, that is distribution line. Okay, that is distribution line. After transforming it a DC to AC, the connection, it's the voltage coming at our home, it's AC. Okay, so that one, it's voltage is stepped down. Normally 132 kilovolt or 11 kilovolt. You have here this one, this 11,000 volt, kilovolts. and 230 is connected at our home. Okay. Then one thing is radial distribution system. What is radial distribution system? Radial distribution system, from the figure you can see, a radial distribution system is a type of power distribution network wherein each circuit originates from a common source or substation and branches out radially to supply individual loads and customers or consumers. Okay, it is very simple and economical. You can see here, this is one substations. Okay, only one substation is here, and all the connections going out from here. Okay, here only two connections are showing, one connection here, one connection away. Okay, so this is the radial. We'll see other connections, then you'll see why we are talking about this radial distribution system. Okay, radial is only from the nearby substations. From the substations, it is all the connection, all the distribution lines are going. Okay, there is no interconnection, or there is no more any other substation connected to this particular substation. Okay, so that is radial distributions. Radial distributions means, let me clear it, only one substations are connect, distribution lines are coming out from it. Okay, to fulfill the demand load. It is simple and economical. So normally this radial substation is normally rapidly or maximum time it is used. Okay. Okay, transmissions we are not going on other. Okay, reliability of a radial distribution system. Okay, system is poor. Okay. Reliability of a radial distribution system is poor, and if there is fault in line, it can interrupt in energy supply. Okay, it can interrupt in energy supply because only one substation it is coming. Okay, and there is no interconnections between the lines. Between the lines means these lines, these distributions lines, and these distributions, this feeder are not internally not connected. Okay, this feeder is not connected to this feeder. Okay, this is, there is no connections. Got it? But here, so if there is any fault, if there is any fault, suppose here in this position, if there is any fault, so if there is any fault in this place, there will be these all the loads, or the consumers connected here, here, okay, here this side, all the consumers connected here, they will not get power. Okay, if there is any fault. So that thing we are saying here. If there is a fault in the line, it can interrupt the energy supply. Okay. So to overcome this, there are two types. Two things is single ring and double ring. Okay. Single ring and double ring. Single ring, from the figure you can see, distribution is carried out by forming a closed loop. Two ends are connected together. Okay. Those feeder are connected. Okay. Those feeder line. Okay, that feeder lines are coming out from the substations. Those are internally connected, and the connections is ring type. Okay, single ring type. You can see here. Okay, okay. So suppose here is fault. So other, from other part it will, power will go. Okay, you got it. And there is one double ring. Okay, another one is double ring. Carried look like interconnected distribution systems to minimize the voltage drop at the far ends. The interconnector is used. The only main thing is, from the feeder, main feeder, the far end. Okay, the far end is directly connected. The far end is directly connected. Okay, what happens here? If suppose there is problem at far end, if there is problem, also there is problem. Okay, both connections there is fault. it becomes for uh, the, if some fault occur in both positions. So this load or this consumer, okay, whoever is here getting the power, taking power, they will not be able to take power if there is in these both conditions there is fault. So in that case, we are connecting here one direct from the feeder. There is one direct connection. Okay, to the far end. Actually, this figure can be okay. Suppose we are pushing it the far end. Is connections, one circle connections. This is the last end part. Okay, here this figure is the circle. If you see in this figure, this feeder line going from every connections. Okay, from every connections lines are going. Consumers are connected. Okay, at this far end from the feeder, it's connected through one line. Okay, this is just you can say this is just backup. Okay, so full safety means there will be no interruptions in supply of energy. So that is double ding. Okay, you got it. So that's it, guys. It's a very a small topic we are discussed here. We are not actually we are it's not small. We are not going that much deeply. Okay. So if you have any doubts, you can comment in the comment box. And I'd like to request you to subscribe this channel. Okay. I'm uploading videos on. We will be almost covering all the basic power systems. And my humble request to everyone: please just plant only one tree each Sunday, or only one in a week. According to me, I think like that the only way to fight against global warming is to plant trees. Okay, what do you think? I don't know, but I think this is true. You can just fight against global warming only by planting trees. Okay, I'm also doing. I'm asking you to do also same. And if you want the PPT, it's available. Okay, you can contact me through this email ID. Okay, you can just mail me. So in the next lecture video, we'll covering the last topic of this high voltage DC transmissions line, or you can say HVDC transmission line. Okay, so this one we'll be covering in the next lecture. Okay, so bye bye guys. Enjoy.